What if I told you that a single drop of fuel could transform the way global shipping works? Not in 10 years, but starting today. Cleaner, more efficient, and compatible with the fleets out there. Sounds bold? Well, meet Rob Mortimer, founder of Fuelre4m and the mind behind of one of the most talked about innovations in maritime sustainability right now. He's not trying to replace fossil fuels overnight. He's rewriting the way we use them. Rob, it's a pleasure to have you here today. Thanks so much for taking the time.
Thanks for having me on.
Rob, shipping faces a dilemma. So nearly 3% of global CO2 emissions, costly retrofits, net zero deadline by 2050. Why is everything so tough?
I think at the moment, one of the biggest problems that we have is people are not fully understanding where we are to be able to understand how we're going to get to where we're going to go to. And we've seen over the last few years that there's a lot of talk about sustainability, but everybody's talking about what's going to happen in the future, 2035, 2050 even. And nobody's really putting much attention as to what we're doing on the path there, with lots and lots of complex ideas and lots of complex solutions, but no real clear strategy and path of how we're going to get to 2050. It seems as though it's almost forgotten about.
You say your technology can optimize the combustion of any fuel, old or new. How does it work, and what does it mean for a cargo ship today?
So it works in a very, very simple way, and it works on all liquid fossil fuels, starting from crude. So we actually can help change the API number of crude oil that's being extracted out of the ground, all the way through to petroleum. And that'll give you an idea that if it works on any type of fuel, it's targeting the same type of materials. And very simply, what it's doing is it's looking at any organic material and reformulating the way or the molecules are behaving, making it so that the molecules unwrap and separate. So you've got lots of different particles. And those particles, at the moment, those particles group together and clog together, forming large drops. And it's those large drops that don't allow for timely combustion. And what I mean by timely combustion is that when they're injected into the engine, the large drops, they start burning from the outside in, and they don't have time to fully combust and convert to what we call piston pushing power. And so by breaking those drops down and making it so that those molecules are no longer attracted to each other, if you liken it to magnets, it's like changing the polarity of the molecules so that they move away from each other and they form lots and lots of smaller particles and lots of drops, allowing at the time of injection into the engine better atomization, and this in turn will allow for more complete combustion. So we're not actually doing anything to the fuel other than making sure that the fuel already has its potential energy in there. At the moment, all the fuels that we're using, only a small part of that potential energy is converting into piston pushing power. All we're doing is making sure we're conditioning the fuel so that before it goes into the engine, more of that can combust more completely, which if you're combusting more completely, less goes to the exhaust, producing emissions. So there's double benefit there, is that you're getting more power from the same fuel, more energy released from the same fuel, which means that your consumption will go down for the same power. And because you're combusting more of that fuel, it also means that you've got less going out to the exhaust, so your emissions come down as well.
What sets your approach apart from other green technologies like hydrogen or electric propulsion?
I don't think that we're a set apart. I think that we're a stage before. And what we're concentrating on is making sure that we're making a clear roadmap. And that roadmap is now saying, okay, let's concentrate on fixing the fuel we're using now. So fix fuel first. And all of the other technologies that are coming through, such as hydrogen and electric propulsion, they're all great and they all need to be brought through. We need to find a clear path to making new fuels and making them work better. But at the same time, when you're looking at what's happening with fossil fuels now, despite all of these new future fuels that are coming through, fossil fuel consumption is increasing year on year, not decreasing. Despite all the efforts we're making to bring on methanol, LNG, ammonia, and then onto hydrogen and batteries. So what we're seeing is that the increase in the use of renewables is only addressing the increase in demand. It's not fully addressing the increase in demand. So what we're looking to do is target the bit that we're using now and make sure that we're optimizing that as much as possible. And what I mean by that, for example, if the amount of renewables is 20%, it's contributing 20% to our overall energy, then a 10% increase in renewables year on year is only going to add on another 2% of that. If the demand goes up, it's not even going to address the extra demand of 3% or 4% overall. Now, if we can say that the fossil fuel consumption is addressing 60% of the energy demand, making a reduction of that by 10 to 15% has a much bigger impact than increasing renewables by 10%. And so what we're looking at is rebalancing things on the overall and saying, okay, let's address the fossil fuel issue first, because it's also going to create new baselines. And what we mean by new baselines, when we're doing comparisons at the moment, and you're looking at LNG and methanol and ammonia, it's being measured against what we know about fossil fuels today. Now, if we're changing those fossil fuels and we're bringing it so that they're 15% more efficient and 30 or 40% cleaner, the baseline that you now need to measure these future fuels against has also changed.
Rob, do you have any real-world examples of this working on ships already? What have customers said about the results?
So the most common thing that we get told is that it's too good to be true. And that's when we start going into trials. And we've had varying degrees of success in the trials where we can always spot where the fuel is combusting more efficiently. But unfortunately, one of the big hang-ups that we have in the shipping industry that we've noticed, I come from a telecoms background, and we use a lot of equipment to be able to constantly monitor, and we can go down to the bits and the bytes. But what we find in the shipping industry is everybody's hung up on something called a SFOC, specific fuel oil consumption, but they don't really know how to calculate it. So there's a lot of different averages coming in, a lot of different things that are brought into the equation of SFOC. And one of the things that we've seen is that if you're measuring incorrectly, and that's including the equipment that you have set up, so a lot of people are now moving to torque meters and mass flow meters. If they're not looking at the right things, the data that you've got coming in now becomes a bigger problem than having no data at all. So with the trials and testing that we've been doing, the first thing we have to do is go to make sure that we can accurately assess the baseline of where it is, and then be able to measure the fuel both with technology, but also physically in the fuel tank. So to answer your question directly, we see that the physical fuel consumption always bears out that there's a reduction in the amount of fuel that is being consumed. But it doesn't always tie up with the technology that is saying what the consumption is. And that's because a lot of it has been calibrated against what the fuel used to do rather than what the fuel is now doing. And so we have to work with all of the clients that we're currently in operations with to make sure that they understand that there's a difference between SFOC and the way that is being calculated and SFOC once you start getting the technology right and understanding. The very simple thing that we're looking at here is that to make a change to the fuel, we're looking at the efficiency of the fuel, not the efficiency of the engine, or not the efficiency of the vessel. So we now have to isolate out everything that's nothing to do with the efficiency of the fuel, which means anything which is an external factor. Well, unfortunately, a lot of people are still bringing that into SFOC to try to get the right calculation. For us, the calculation is very simple. How much fuel in mass is going into the engine? How much is returned, again in mass? And what is the power out? And at this point, there are very few ways to be able to assess what the power out of the engine is, which means that we can't understand the MCR of the engine at that point with that fuel. So one of the things we've had to do is design a new system or a new way of being able to measure the fuel's performance, not the engine's performance. And again, it goes back to understanding at what point the power is coming and what MCR or what percentage of the MCR that that's coming from. And one of the things we first do is we look to see what are the constants that we know. Now, one of the constants that we know is that thrust doesn't change against RPM. So that is now a base that we can use. And when we start looking at torque and power, we start finding that anybody that's implementing a torque meter is currently missing thrust from the calculation. Now, thrust is like horsepower from the engine. So we can get a better idea of what the MCR of the engine is at the same time as looking at what the power is. So we're looking at what level the power is being delivered, and what load on the engine the power is being delivered. By adjusting that, we can now start saying, okay, the engine has got an MCR of this, and the fuel has now made it so the MCR is a little bit lower or a little bit higher. So we can now make the proper adjustment.
You call shipping a beacon for sustainability. What does that look like in 2050, and what role does Fuelre4m play?
I think that shipping has a very important part to play, but I also think that it's getting carried away, if you like, in terms of where we're trying to go and what direction and what technologies are going to go onto ships. We prefer to look at fuel and energy as a whole. It doesn't matter whether you're in the shipping industry. We also work into quarrying and mining, trucks and fleets and logistics companies, all the way through to big power plants. Energy is energy. And it's our belief that the right type of fuel should be used in the right application. And we see that there's a big drive towards putting new technologies into shipping. And we start to question as to whether this is the right and the safest direction for shipping, or would it be better to put things like ammonia and hydrogen on land in controlled environments and carry on using fossil fuels if we can make those fossil fuels better? The overall result will be that we're using a safer technology on land where we can control it better, but we're still reducing the amount of fossil fuel that's being consumed on land, which now means that the overall impact in the shipping industry is that they might still be using fossil fuels, but better, and we can use more scrubber technology like ultra low frequency scrubbers and lots of other different types of technology to try and make it so that we're bringing the emissions down. But we have to start looking a little bit past just concentrating on the shipping industry and looking at global energy and working out which technology, which fuel technology is the best technology for which environment.
Rob, what's your message to ship owners and innovators ready to act now?
My message to ship owners and innovators ready to act now is hold back. And, there is a lot of talk about dual fuel engines. And quite frankly, when you're talking about dual fuel ready, the realization is now starting to come is that dual fuel ready is nothing more than saying that you're ready to go and implement a technology that you can't exactly implement right now. There's a lot of moves now to try and understand what technology is going to become available or should be available in 10 years' time or over the lifetime of the engine. Our message is you don't need to panic. You don't need to go into these new technologies until they're proven. And we think that every new fuel technology that comes through should be proven and measured in the same way as what we have existing. Our message is that you can meet all of your IMO and other regulatory requirements just by treating your fuel and measuring it better. And this is even without using Fuelre4m's Reformix products. And what I mean by that is that when we get involved with trials, it's very often evident, or it becomes evident, that the consumption is unknown on that vessel. It's not very accurate at all. We're using SFOC, and we see that there's a lot of leeway in that. So just by understanding your complete fuel system, and we have a version of trials which now talks about complete fuel system lockdown. And what we do with complete fuel system lockdown is we make sure that from the time that the fuel is coming onto the vessel, we're measuring and monitoring from the bunker tank to the settling tank, from the settling tank through purification into how much fuel is going into the engine. We're monitoring all possible ways through the return of how that's going to come back and making sure that we have tank sensors as well on that. Just by monitoring the fuel and understanding exactly where it's going and exactly what changes you're making are impacting your SFOC and your grams per kilowatt hour, putting that type of scrutiny on your fuel system now means that you're going to reduce your consumption without putting anything in there, just by understanding how much fuel is actually being used rather than what is reported on a noon daily report. So our message is quite clear. We're saying, let's worry about the fossil fuel of today that we're still having to consume, because it still plays the biggest part and it's where you can make the biggest impact. And it's the easiest and most cost-effective way to gain compliance. If you're reducing your fuel consumption in any way, it means that you're going to be less liable for all of the taxes that are being implemented around the world. And it also means that you've got a better baseline, a lot more accurate baseline to understand the new technologies and what they're going to do for your operation. So for the next 5 to 6 years, we've got you covered without it costing you anything. No retrofits, just drop it in, and then we'll help you measure the fuel.
Your invention, that really sounds amazing. Let me add a personal, or rather more personal question. What personally drove you to start revolutionizing fossil fuels in the first place?
It was almost quite by accident. My background, I'm an engineer by trade, and I come from the telecoms industry. And I designed a hybrid generator, and the hybrid generator changed the dynamics of how people were looking at power generation. A lot of people were going to solar power and making smaller engines and charging batteries. I flipped it on its head, and we did a bigger engine, bigger battery bank, and charging the batteries from the bigger engine for a shorter period of time, which got 80% fuel consumption reduction. At the same time as doing that, we're then looking to see how we can optimize the whole system better. And somebody quite literally came to me with a little bottle, a little water bottle that had some of this magic liquid in there, and said, "Try this. It's going to make your consumption down, and it's going to make the fuel smell better, meaning the emissions are going to be better." And everybody else told me we were crazy if we even considered it. It was snake oil. Now, I'm a little bit, I would say a little bit competitive. And it was when somebody told me that it didn't work and wasn't possible, that I decided we're going to give it a go. And we spent 6 months working now trying to understand exactly what this product did. And the drive there was, once we realized how special this was trying to make sure that everybody understood that the baseline that we have for fossil fuels is wrong, and that we can make them burn more completely before they even get to the engine. The further we got into it, the further we started to understand that this isn't even within the engine manufacturer's gift. And when we started talking to the large companies like MAN, for example, and when we spoke to MAN, they were telling us how their engines are the most technologically advanced and the best performing. And we said, yes, there's nothing we can tell you about how to make a better engine, but we can tell you about how we can improve the fuel to make your engines even better. And it was the realization, that was about 4 years ago, there's a realization that the fuel itself was the area where we have the biggest chance of making a difference. And what we've seen over the last few months, certainly with the politics that have gone in America, and the industry is, or the fossil fuel industry is now been reborn, because everybody's understood we can't ignore the fossil fuel. We can't move away from it. So why don't we try making sure that every drop that we use is optimized and is working as effectively as possible?
Everybody is talking about big data, data analysis, and making a better use of data. So what role does that play in your view?
One thing that we're seeing is that data analytics is now becoming a very big business, but, and it's a big but, is that most of the data analytics companies, they understand how to analyze data. They don't understand where it's coming from. And there's a very, very big difference there. And what we mean by that is that when you're taking data analytics, that if you've got a torque meter, everybody assumes that the torque meter is outputting torque. It's not. It's outputting shaft twist. And at the same time, you now have to look at where that relates, as in MCR of the engine. If you don't have the full picture, and I think that one of the things we do want to articulate is that fuel is a 4D picture. On any vessel, it's a 4D picture. You've got to be looking everywhere, because if you change one thing, you have multiple changes going on through the vessel and through the operation. And unless you've got the willingness to try and spot where those changes are occurring, then it could look as though you haven't made any improvement. But the biggest part from that is that to date, we haven't seen any setup that is using a torque meter that can spot the difference between external factors and internal factors or the fuel. If you've got a different baseline, so if you're starting from baseline point on your torque meter and you're saying, this is the torque at this MCR, but your MCR has changed or your engine loading has changed, you're now measuring a variable with a variable, and it can't be done. And until the shipping industry understands that there are different things that you've got to look at in this picture to understand what has changed and how to offset it, the data just isn't correct. Now, one of the things we've seen when we came into this is that we've been told that we've tried additives and they don't work. And we've tried this and it doesn't work. And we've tried something else and it doesn't work. My challenge is, have you really understood what your fuel consumption was first and the power of the fuel before you start measuring whether something is working or not? And I think that challenge will be 100% of the time we'll find that nobody actually knows what is the external forces and what is the internal.
One drop that redefines what's possible in shipping. Fuelre4m is proving that innovation doesn't have to wait for the future. Thanks so much, Rob, for sharing your vision. There's definitely a space to watch.